Hi, my name is Eugene Stepanov. I'm a senior database solution architect with AWS. Thank you very much for giving me this opportunity to be part of your event. It's a pleasure and a privilege. Here at AWS, I focus on SQL Server and Postgres. So topic of our today's session will be running managed SQL Server workload on AWS. Now, those of you who are new to PaaS, you have come to the right place. Please check out our website, paas.org, and check out all educational resources that are available on the website for our members. Let's learn year-round. Learn, share, and connect. All right, before we begin, I'll just say a few words about myself. As I mentioned, name is Eugene Stepanov, and I've been in software development for 20 plus years. I stopped counting. I started as the presentation tier development, web development. Then I moved to middle tier development. But since about 2005, I started focusing on the backend, started focusing on relational database management systems, and never looked back. I worked with every single version of SQL Server since 7.0, and that's a long time. I worked with a large number of companies, large and small, and I joined AWS about 2 years ago, and prior to that, I worked for Microsoft. And I'm based out of Seattle, Washington, and I absolutely love Pacific Northwest. All right, please don't forget our session evaluations. Please submit them by November 20th, Friday. It is very, very important. Your feedback is very important. That's the only way we get better at what we do. With that, let's jump straight to the agenda. First, we will take a look at two main ways of hosting your SQL Server workload on AWS, and that is EC2 and RDS, and we will compare them. Then, we will take a look at managed experience of RDS, automated backups, high availability, readscaleout. We will take a look at the great tool called Performance Insights. Then we will take a look at some of these building blocks of RDS and AWS in general, and that is compute instances and storage subsystem. Then we'll take a look at the very common scenario, and that is Active Directory integration. It is a very popular scenario, and RDS does support AD integration. Then we'll take a look at the performance monitoring and see what are the tools that are available to monitor your performance on RDS. Then we will take a look at some of these ways you can move data in and out of RDS. Towards the end, we will take a look at new features that we released recently, and I am sure many of you will be very, very excited. And towards the very end, we will take a look how you can deploy and manage your RDS SQL Server. With that, let's jump straight to it. Amazon RDS. Those of you who are not familiar, RDS stands for Relational Database Service. RDS has been built with a single mission in mind, and that is to free you up, you our customer, from responsibilities and tasks that take a lot of time for our system administrators and database administrators on a daily basis. Setting up sound backup and restore strategy, setting up high availability, operating system level maintenance, database engine level maintenance, just to name a few, to free you up so you can redeploy those very valuable IT resources to projects that deliver value to your customers, projects that differentiate your business from the competition. Now, this slide right here shows two main ways of running your SQL Server workload on AWS. I'm obviously using SQL Server as an example here, but this diagram will be exactly the same whether we're talking about SQL Server, Oracle, or MySQL, for example. So on the right, we've got SQL Server running on Amazon EC2. And for those of you who are not familiar, EC2 stands for Elastic Computing Cloud. So, and what this involves, essentially, It involves launching a virtual machine on the cloud, and then you would install your own database engine on that virtual machine. And from that point on, running a SQL Server on AWS is not too different from the way you run your SQL Server in your own virtualized environment. Now, color coding here, the gray stands for customer managed, right? So you would be responsible from the very top. You would be responsible for things like scaling it up and down, for high availability, database and restore, for database management patching, database management installation and maintenance, OS level patching. Those are all your responsibilities. And at the very bottom, things that we, AWS, will be responsible for. So this is obviously at the very bottom, the hardware, and then initial operating system installation and maintenance. Now, let's contrast that with a diagram on the left. And that is running your SQL Server workload on RDS. And as you can see here, all of it is now AWS managed. We, AWS, deliver scaling, deliver high availability, deliver database backup strategy to you as the managed experience. We would also take care of the patching, OS level maintenance, engine level maintenance, and obviously the OS installation and hardware. We deliver all of these things to you as the managed experience, so they literally become a checkbox somewhere on the console. I'll use high availability as an example. Those of you who have set up something like failover cluster instances, or possibly always on availability group, or maybe database mirroring or TLOC shipping, know how involved that process is, how many moving parts to it. Here on RDS, it becomes literally a click on the radio button, and if you click a multi-Z option, we will deploy a second hot synchronous standby. We will put it in the second availability zone, and we will monitor and we will maintain a listener endpoint for you. So all your application has to do is to connect to that listener endpoint, and God forbid something happens with your primary, all your application has to do is to have a retry logic that reestablishes the connection and re-executes the same SQL. No changes on the application side. All right, now let's take a look at what's available on RDS and on EC2. So from the very top, in terms of versions, RDS supports all supported versions from 2012 to 2019. On EC2, obviously, you are master of your own destiny. As long as you have a licensed media, you can install it. It is your virtual machine. In terms of edition supported, we support Express, Web, Standard, and Enterprise. Again, on EC2, as long as you have licensed media, you can go ahead and you can install it. Nobody's going to stop you. High availability, as I mentioned, comes to you as AWS managed. It's a click of a button. On EC2, again, self-managed. Whether you build always on availability group, mirroring, or failover cluster instances, that is your choice. This is your design. This is your implementation. This is your maintenance. Encryption. We support all native built-in SQL Server features. We support TDE. We support column level encryption. We support always encrypted, as well as TLS for encryption in flight, as well as AWS specific, which is EBS encryption, which is very similar to that of TDE in a sense that it uses the same cryptography, advanced encryption standard 256, and it encrypts the content that's been stored on EBS volume, but it is a whole lot easier to set up and manage. In terms of authentication, we support both Windows and SQL authentication, and we will talk about that. We will talk about ways you can join your RDS SQL Server instance to an existing Active Directory. And as far as backups comes to you, again, as a managed experience on RDS, on EC2, that is all on you, or your responsibility, your design, your implementation. And as far as maintenance, again, RDS is automated software patching, and on EC2, it is all self-managed. All right, this screen here is meant to give you a very high-level checklist that might help you to decide which way to go, right? So let's take a look from the very top. License included model is supported on both on EC2 and RDS. Next one, bring your own license, BYOL. Unfortunately, only EC2 is support that licensing model. RDS does not. So, if you've made, if you have an existing investment in SQL Server license, and if you have maintained active software assurance, then EC2 is the only option there. Now, if the third one from the top, if your application requires full control over the instance, if you need full control over the OS, or you need SA access to your SQL Server instance, that is also supported on EC2. RDS does not support that. And then at the bottom, automated backups, automated and AWS managed multi-Z or high availability, AWS managed readscaleout, and AWS automated ability to scale compute and storage easily and independently. That is all features of RDS on EC2. That all is self-managed. All right, and now let's take a look at some of that managed experience that you receive on RDS. Managed experience. Let's start maybe with backup. Those of you who set up a backup strategy on-prem, you have probably done something like full backup on the weekend, and then maybe differential backup every day, and maybe T-log backup every 5 minutes or so, right? That's pretty standard. Now, here on RDS, it's managed. It literally becomes a checkbox and a drop-down. And in that drop-down, you can select any number of days from 0 to 35, and we will maintain an unbroken chain of backups for that many days. Default is being 7 days. Now, the way we implement our strategy, we take a full EBS snapshot every day, and then we take a T-log backup every 5 minutes. So that gives you the idea of the granularity of that point in time restore. Again, T-log is being taken every 5 minutes. And again, the maximum retention, maximum number of days that you can retain is 35. Now, if you need more than 35 days, there is another feature, and that's called a manual snapshot. Manual snapshot is essentially an EBS snapshot, but it is managed by you. So you manage the entire life cycle of the manual snapshot end to end. You trigger your snapshot, you take it, and then you can keep it indefinitely if you want to. RDS will charge you for the storage. Now, you're probably wondering, stop, what about native backups? Can I do native backups on RDS? And the answer is yes. Native backups have been such an important part of the SQL Server ecosystem that our platform wouldn't be complete if we wouldn't support this feature. Now, but since there is no access to the underlying operating system or file system, it works slightly differently. You don't back up your RDS database using backup database command. You back it up by AWS provided storage procedure, and it is on the screen right there. You kick off that storage procedure, and then you point, one of the arguments there is your S3 bucket. So we will back it up for you, and we will place your .back file into your S3 bucket. And after that, it's yours. You can download it. You can bring it on-prem. You can do whatever you want with it. Now, it also works the other direction. You can back up your existing SQL Server database on-prem. You can upload that file into the S3 bucket. And there is another reciprocal storage procedure, very similar to that one that you see on the screen right now. It's just called RDS restore database. And we will restore a database from the native backup you just uploaded to S3. And by the way, this is a feature that is very widely used for migrating your workloads to RDS. All right, high availability. Probably the second most important, or probably the most important, dependent on your situation, is high availability. Now, again, as I mentioned, there are a number of built-in features, such as failover cluster instances, always-on availability group, database mirroring, TLOC shipping, possibly even transactional replication that people do use to set up highly available SQL Server deployment. As I mentioned before, here on RDS is just a checkbox. You click that checkbox, it's called multi-IZ, and we will deploy a second synchronous hot standby into another availability zone. Now, the native mechanism that is used for multi-IZ is different depending on version and edition of SQL Server that you use. Now, for 2016 and for 2017 Enterprise Edition, it's always on availability group that's used for that multi-IZ. For older versions of Enterprise Editions and for all standard editions, it's a database mirroring that is used to deliver that multi-IZ experience. And again, I repeat, it's going to be a synchronous hot standby. There will be automatic and manual failover available. We will monitor, and again, something happens with your primary, either it's a compute node crash or a storage subsystem crash, or God forbid, maybe entire availability zone goes down. We will automatically fail over. And as I mentioned, all your application has to do is to have that retry logic to reestablish the connection and to re-execute the same SQL. Now, it's important to remember that no read traffic is allowed against that hot secondary standby. If your intent is to do something like application intent equals read only, and you're hoping to get at that hot standby to offload your read traffic over to that secondary, that's not gonna work. That hot standby is reserved exclusively for the failover for high availability only. Very, very important to remember. Now, next slide, real quick. I don't want to spend too much time here, but in terms of failover times, If you rely on always-on availability group, and that's again 2016 and 2017 Enterprise Edition, we rely on always-on. And if your application is written using relatively modern .NET framework or any other framework that supports that multi-subnet failover equals true setting, then you can expect your failover time to be in the single-digit territory. Very, very, very important. Just a note here that the crush recovery times is not included in those numbers. Very, very important to remember. All right, so that's high availability. Next one, read scale out. Again, those of you who deployed something like always on availability group to scale it out know how involved that process is. Now, here on RDS, it's just few clicks, and you can deploy up to 5 asynchronous read replica, in-region read replica. Very important to remember, up to 5 only as of right now, and it's asynchronous only. You cannot change that behavior. We're not exposing the APIs to flip that to a synchronous commit. And it is Enterprise Edition feature, and it is supported started from 2016 and above. Now, there is no failover. There is no automatic or manual failover to speak of here. There is a process called promotion, but this is something completely different, right? With failover, you can fail over and then you can fail back. The failover event, doesn't change the configuration of your cluster. Now, what promotion does, by the end of the promotion process, what you end up with a standalone SQL Server instance that has no relation to the original cluster anymore. Very, very important to remember. All right, compute and storage scaling. This is the fun one, and we've always been there, right? Scenario is simple. We have outgrown the physical capacity of our box, or possibly physical capacity of our storage subsystem, and we need a bigger box, or we need more performance storage subsystem, and with that comes the migration, and we all know how painful that can be, and usually is. Here on RDS, just like with anything else, it's just a few clicks of a button, and you can scale up all the way up to maybe our largest instance, maybe something like R5 24x large that comes with 96 vCPU. Or maybe if your workload is seasonal, and maybe as the cost optimization technique, you can scale down to meet the actual need of your business. And again, this is really easily done. As far as storage subsystem, you can absolutely scale up your storage to a larger data sets, and you can also with the IO1 or provision IOPS, you can also scale the performance of your storage subsystem, and we will take a look at it a little bit later. Now, the last feature in my managed experience section is a tool called Performance Insights. And Performance Insights gives you a database engine level visibility into the performance of your instance. And now, when it comes to monitoring performance on-prem, I'm sure you've used native built-in features like SQL Profiler and extended events, and possibly the DMVs and DMFs, as well as maybe third-party tools like Redgate, SentryOne, Foglight, and such, and all of them are great tools. What sets Performance Insights apart from many of them is the fact that we were able to boil down performance to a single metric called average active sessions, and being able to slice that metrics by weights, by SQL, by hosts, or by users, and color code and build great visualization like this. The second point I wanted to make about the Performance Insights is the fact that whether you work with SQL Server, Oracle, MySQL, Postgres, the tool is exactly the same. The look and feel is exactly the same. What is different, the only one thing is different, and that weight types, because weight types are engine specific. Now, and if you choose to keep only up to 7 days of telemetry, this tool is absolutely free of no charge. If you decide to keep your telemetry for a longer period of time, there will be a storage charged associated with it. But again, up to 7 days, and it is absolutely free to use. And the reason why I keep it here in my managed experience section is because it is built into RDS. All you need to do is enable it, which is the checkbox, and then you don't need to install it, you don't need to maintain it, you don't need to acquire a license for it. It is absolutely part of that managed experience of RDS, and it's a great tool. Our own support using this tool to watch out over the RDS fleet. All right, with that, let's jump back to our next section, and that is taking a look at some of these building blocks that RDS and AWS are built with. All right, we'll start with our compute instances. We'll start with available instance types. Now, it's not the purpose of the slide to give you every single instance type that is available on RDS. As many of you probably are aware, AWS has over 200 different instance types. Here on RDS, we select only the instance types, only the families that make sense in the context of database workload, because obviously RDS is all about relational databases, right? So we've selected a few families, as you can see. Our M is the general purpose family, and R is our memory optimized family. Now, it's all about vCPU to memory ratio. As you can see here, in the M family, X large T short size comes with vCPU and 16 gigs of RAM. In R5 family, the same X large T short size comes with 4 vCPUs and 32 gigs of RAM. Now, if you would like to have even larger buffer pool, maybe X1E is the good choice for your workload, because the same X large T short size now comes with 4 vCPUs and 122 gigs of RAM. And again, a lot of different T short sizes available, all the way up to, say, 96 vCPUs in our family, which would be 24x large. Now, we also, not too long ago, we launched a Z1D family, which is our CPU optimized family. This family is built using very fast Intel chips. These are 4 gigahertz chips. So if you are compute bound, maybe Z1D would be a good fit for your workload. And for smaller workloads, we also have burstable T2 and T3 family. Again, for very little smaller workloads, you can take a look at that family. All right, so that's instance types, and now let's take a look at our EBS service. EBS stands for Elastic Block Storage, And essentially, for those of you who are not familiar, essentially what it is it's a solid state device that's been attached to your compute instance over the network. Now, there are two storage classes that are supported by EBS. The first one is general purpose, or GP2, which is very cost-effective storage subsystem, and it is suitable for wide range of workloads. Now, there are some numbers here, some characteristics. You can read them yourself. I'm not going to do it for you. But if I were to point out a couple, I would say the first is the fact that the amount of IOPS, or performance you're going to get out of your storage subsystem, is tightly correlated with the size of the volume. So the bigger the volume, the more IOPS you're going to get out of your storage. And the second is the fact that GP2 has been designed to deliver actual performance 99% of the time. So that's the first, general purpose, or GP2. And the second storage class is what we call provision IOPS, or IO1. And again, there are some characteristics, you can read them yourself. But again, if I were to point out a couple, is the fact that now this storage class has been designed to deliver performance 99.9% of the time. And now there is ability to scale performance independently from storage. So you can pick a relatively modest size volume and scale up its performance to a high number. And we usually recommend provision IOPS, or IO1, for IO-intensive database workloads. All right, that concludes our building blocks section. So we just took a look at our compute instance types and our storage subsystem. Why don't we go back to the agenda and see how we're doing? So we've covered EC2 versus RDS. We took a look at some of these managed experiences. And then we took a look at our compute nodes, or family types that are available for RDS, and the storage subsystem that's available. So now we're coming up on Active Directory integration, which is a very, very common scenario. And essentially, scenario is simple, right? And I have these conversations with my customers on a daily basis. They tell me, hey, seems like RDS can be a great platform for my workload. I absolutely willing to give it a try, but I have my Microsoft Active Directory. It is currently on-prem. I use it as my identity store, as my permission store, and I have no intention of giving that up. How do I join my RDS instance to the existing Active Directory? And it is a supported configuration, but all it requires one additional step, and that's right there in the middle, where you see Microsoft Active Directory managed by AWS. So essentially, you cannot join your RDS instance directly to your on-prem Active Directory, or even self-managed Active Directory on EC2. This intermediate AWS managed directory is required. So you would launch in the same region as your RDS instance, you would launch your AWS managed directory, and then you would establish a one-way trust. You can establish two-way trust. That'd be your choice. We're not requiring that. In order for this to work, one-way trust is sufficient. in which case your on-prem Active Directory becomes trusted and your AWS managed directory becomes trusted. So those tokens only fly one way. And the same configuration would also be supported if you were to have this self-managed Active Directory on EC2. Essentially, you can have it running on EC2, then have AWS managed Active Directory. Again, you would establish one-way trust, and then you can join your RDS instance to AWS managed directory supported scenario. That brings us to the end of this topic, and let's jump straight to performance monitoring. All right. Now, performance monitoring is a huge topic. 1 hour wouldn't be enough, obviously, if we were only to talk about performance monitoring. So I'll give you a 30,000 feet view, holistic view on what is available on RDS. Now, when you were on-prem in your self-managed environment, you obviously used a SQL Server native built-in functionality like DMVs and DMFs and SQL Profile and short query plans and extended events and great tools like that, right? On top of that, you probably rely on some third party like Ola Hollengren scripts and tool from SentryOne, Redgate, Foglight. There are so many great tools available out there. And we're not taking away those features from you on RDS. The way to think about it is that if a particular feature does require SA access, it would not work. If it does not require SA access, it would work just out of the box. Now, SQL Profiler, for example, does not require SA access. You can use SQL Profiler. Short Query Plan doesn't require SA. Most of the DMVs and DMFs don't require SA, so you can absolutely use them as is. As far as third-party tooling, well, RDS is a well-known platform for hosting your SQL Server workload. So many of these vendors, SentryOne, for example, build the RDS specific version of RDS tool. Now, on top of that, on top of number 4 and number 5, we also have RDS or AWS specific tools. So I'll start with CloudWatch. Number 1 on my list there, CloudWatch. And what CloudWatch is, essentially CloudWatch is a central repository of a telemetry that can be collected from all kinds of different services and places. And they've been collected, and then they can we can build visualizations and stuff like this. So it's important to remember that CloudWatch also available on RDS, and it's important to remember that CloudWatch is a hypervisor level set of metrics. Then number 2, we have enhanced monitoring. Enhanced monitoring is similar to that of CloudWatch Metrics in the sense that it's also a collection of telemetry, but that telemetry now being collected at the OS operating system level, not the hypervisor OS level, right? And then performance insights, the tool that I already showed you, and again, a great tool built into RDS platform, being delivered as the managed experience. All you need to do is enable it, and up to 7 days of telemetry is absolutely of no charge. All right, CloudWatch Metrics. So you can see a list here, close to a dozen probably. You can read the list yourself. I'm not going to read the entire list, but to pick just the handful of very important ones, obviously CPU utilization, queue depth is another very important that shows you what is the length of your queue of your storage subsystem. What else here? Read and write latency, and then network receive and transmit throughput. Very informative, very important metrics. And as I mentioned, RDS enhanced monitoring. This is agent-based OS level telemetry that is collected at the OS level by that agent. And it's important to remember that it's possible to see some difference between the CloudWatch metrics and the enhanced monitoring metrics. And obviously the difference is due to the collection source, right? It's the hypervisor versus the OS. All right, and there are 26 metrics. I'm not going to list them all. We're not going to have time to look at them all. Please check them out, and you can configure up to 1 second granularity for those metrics. All right, that is all in the monitoring section. And now let's go ahead and let's take a few minutes talking about migration to RDS. How do you move data in and out of RDS if you have to? So you can read the slide yourself. There are quite a few. There are 5 options here, and if I were to pick out just 2, I would say by the large margin, just bringing the native backup file, putting it into the S3 bucket, and then restoring from it. And as we talked before, it also works in the other direction, where you back up your RDS instance. Your .back file is being saved in your S3 bucket, and that's where you can download it from. This is by far the most popular way of bringing your SQL Server to RDS. And obviously that works. That is simple and straightforward, right? It's just a native backup. But obviously it requires downtime. And the downtime is the amount of time you need to produce your backup on-prem, upload it to S3 bucket, and then restore it from it. Now, if you have a requirement to minimize that downtime, then you need something like closer to a real-time replication, or possibly a change data capture. So then AWS has a database migration service, and that is number 3 in my list. And essentially, database migration service is a replication engine. You spin up a DMS instance, you configure your source endpoint, your target endpoint, and then database migration service will start mining the transaction log on your source, bringing all those physical changes down to the replication instance, do a logical decoding, and then applying those changes as the T-SQL statements against the target database. And DMS is great service, very popular, and we put lots of mileage on that service since its inception. So now there are obviously a couple other options here. Number 2 works for smaller databases. There are a couple of third-party tools that are available on AWS Marketplace. Please check them out. we're not gonna have time to talk about them all. And number 5 is also something that can be configured. You absolutely can configure push subscription and do transactional replication from on-prem over to RDS. But that feature does not work in the opposite direction. You cannot replicate out of RDS. All right, and that brings us to the end of this section, and let's talk about my favorite section, and that is new features of RDS SQL Server. We've been busy, and we've released quite a few major features, and I hope you will be as excited as I am. From the very top, Enterprise Edition Multi-Z price reduction. This is a good one. There's not much to say here. Please follow that link if you not aware already. In July of this year, we reduced the prices for our multi-AZ deployments, and it can average up to 25%. Again, please follow that link if you're not aware already. Number two, cross-account and cross-VPC domain joins. So we've talked about Active Directory integration case as a supported use case. But prior to this release, your managed AWS managed Active Directory would have to be in the same account in the same VPC as your RDS instance. Now, for the companies, for the customers with the larger footprints, where they have so many of them, and possibly spread across different accounts and different VPCs, that presented a challenge. So not too long ago, we released cross-account, cross-VPC domain join feature, where now you can join your RDS instance to an managed Active Directory that is sitting in a different account in a different VPC. Very, very important feature. The number three, ability to disable older versions of TLS and ciphers. Very, very important for regulated industries, for the folks that are worried about different compliance frameworks, where you need to be crystal clear on what version of TLS supported and which version of TLS has to be rejected. Very, very important. If that's your case, please follow that link, and you can find a blog post where we take you step by step on how you can disable these older versions of these protocols. Number four, SQL Server integration services. Now, SQL Server integration services has been such an important part of SQL Server ecosystem that many BI workload relies on those tools. And prior to this release, you could still use integration services, but you would have to host them, host the service outside of RDS, right? And obviously that required additional EC2 instance, which is suboptimal from the cost perspective, because you not only need an additional EC2 instance, but also another SQL Server license. So in April-May timeframe, we released support for SSIS, and now you can host your packages, your SSIS packages on RDS instance itself. If that's something you do, please follow that YouTube link, and we have a great video where we take you step by step on how to prepare your SSIS package, how to bring it to RDS, and how to deploy them to RDS and execute them. Number five, SQL Server reporting services. Very similar to that of integration services story, right? Very, very important for business intelligence applications. And again, prior to this release, you would have to host your reporting services outside of RDS. And now you can bring your RDS, bring your SSRS solutions to RDS. And again, if that's something you're interested in, there is a YouTube video where we again take you step by step on how to prepare your RDS instance, and how to upload your RDL reports. The next one, number 6, SQL Server Analysis Services. Another component of Microsoft BI stack. Currently, we support tabular models only. There is no multi-dimensional model support as of now. And again, if that's something you do currently, please check out that YouTube video, and we again take you step by step on how to bring your tabular models over to RDS. Number 7, and we spoke about this already, in-region read replicas. It's a relatively recent release. You can now launch up to 5 asynchronous read replica. If that's something that interests you, please follow that link. There is a YouTube video where I take you step by step on how to set it up. And I'm talking about some of the limitations that this feature comes with, as well as an architecture deep dive on how we implemented it. I'm talking about the distributed availability group that backs the in-region read replica feature. Very, very cool feature. Number 8, Microsoft Distributed Transaction Coordinator. There is a blog post, there's documentation, and soon there will be another YouTube video on how to set it up. And essentially prior to this release, it wasn't possible to have your RDS instance to be a participant in the distributed transaction. And now you can have the MSDTC service running on your RDS instance. And we support 2 use cases for this service. We support running distributed transactions over a linked server, or there is another use case where we support a distributed transaction that's being controlled from the client side, from the application side. And it requires setting up a C# project and controlling your transaction from the code. Next one, replicating service master key is feature important for things like distributed transactions and ability to execute USSIS packages from the SQL agent job that requires setting up a proxy. Very, very important. Please check it out. Follow that link. And the next one, a multi-file backup. Wow, that's important for multiple reasons. First of all, I'm sure you're aware that S3 service has a 5 terabyte limit at the object level, which means that prior to this feature, prior to this release, you could not produce a native backup on a database that is larger than 5 terabytes. So now by using multiple files, you can back up much, much larger databases. The next reason is by using the multi-part, multi-file upload, you can greatly speed up the process of uploading these files over to S3. And plus, by backing up to multiple files, you can greatly reduce the time it takes to produce the backup. That is good all around. Which brings us to the end of this section. I hope that was beneficial. And now, essentially my last slide. And here I just want to mention how you can deploy and manage your RDS SQL Server. And obviously, everything we talked about can be done on through the Management Console. And to work with your infrastructure as a code, obviously, command line interface is available, and SDKs for most popular development environment is also out there. as well as our AWS Cloud Formation service, which is ability to construct these templates and work with your infrastructure as code. So that brings us to the end of this session. And please engage with us. We're going to have our virtual booth video chat Friday, November 13th, and there are a couple of time slots, 4:45 p.m. to 5:45 p.m. Eastern, and then 7:15 p.m. to 8:15 p.m. Eastern time. Please join us there, and please don't miss our upcoming AWS session. We will be talking about SQL Server Business Intelligence on RDS, and that's Friday, November the 13th. 6 p.m. to 7:15 p.m. Eastern. And that brings us to the very end. I hope that was beneficial. Thank you very much for giving me this opportunity. It's a pleasure and a privilege. And I believe we have a few minutes left for a couple of questions. So let's go straight to Q&A. Thank you very much.